So in the previous class, we have gone through the fundamental concept of the electrical engineering. So in that we have studied that electric charge and current, and what is electrical potential, and what is the electrical potential difference, and electrical power and energy. So these types of concept we have already gone through. So in this session, so we're going to see what are the basic elements of the electrical circuit. So the first basic element of this electrical circuit is resistor. So how will you define what is meant by a resistor? And the definition of the resistor: this is the property of the resistor. It opposes the flow of electrons or flow of current. It is the property of the resistance. It will opposes the flow of electrons or flow of current, and it is measures in ohms. The symbol is this one. And if you see the electrical equivalence symbol for this resistance is like this. It is denoted with this particular symbol. Whenever you see this kind of symbols in your concept, so that is assumed as a resistance. Now we'll see the resistance of a conductor. What is meant by resistance of a conductor? So before going to this, I just wanted to define a term. It is called the conductor. I need to define the term is called conductor. So conductor is the property of the conductor material. It allows the flow of electrons. It allows the flow of current. So this is the definition for conductor. It allows the flow of electrons, or it allows the flow of current, or it conducts the current. So that is what the definition for this. Now to understand this concept, what is the resistance of this conductor? So let us consider a conducting material or conductor, some conductor of some material which has been made of, assume it is aluminum conductor, and this has the length L, and the cross-sectional area of this conductor is A. And as you know that when you talk about the ideal conductors here, so the property of this ideal conductor, the conductivity, the conductance of this conductor is 100%, or you can say the conductivity, the conductor, the resistance of this ideal conductor is 0. The ideal conductors, the resistance of the internal resistance of this particular conductors are 0, or it is a 100% conductivity property. Our conductivity of this conductors are, we can say, the infinite for ideal conductors. So this is the definition, or some points you need to remember for that ideal conductor. But when it comes to that practical conductors, in the practical conductor, this conductor does not conduct 100% conductivity, but they have some internal resistance. And assume for this particular conductor some resistance, the property which is try to opposes the flow of electrons, flow of electrons, and that is the internal resistance, some value which is exist in this particular conductor. Then if you write what is the resistance of this conductor in relation with cross-sectional area and length of the conductor, then R is directly proportional to length upon your cross-sectional area. If you remove this proportionality constant, then resistivity is the constant will come rho L by A. This is called the rho and resistivity constant of the conductor. Resistivity constant of the conductor for the conductor. So this is what the concept of your conductor. And if you see here the conductance, conductor or conductance, conductor, if you are saying it is denoted with Z. So if you compare what is resistance and what is the conductor, the resistance is opposing the flow of current, but my conductor allows the flow of current. So I can write R is inversely proportional to Z, where my resistance R can be measured in ohm, and my conductance can be measured in mho. So these are the measuring units for your resistance and conductance. Now comes to the another element of my electrical circuit. The another element is called inductor. Inductor. Inductor L, and if you see the electrical symbol for this inductor is could be like this, inductor L. So what is the property, what is the definition of the inductor? So inductance is the property of the inductor, is the property, inductor is the property of inductance is the property of inductor. It allows, it opposes the change in current. It opposes the change in current. So that is the definition for your inductor. It opposes the sudden change in current. Suddenly, if current changes, and this can be measures in Henry. The units for this is Henry, or you can write as H. It is like 1 Henry, or 2 Henrys, or 3 Henrys. These are the values for your inductors. So very detailed concept, what is inductor and what is the property and how this inductor L is relation with your current and voltage. Those kinds of concept will be going to see in the coming classes. For understanding the basic elements, you just remember the inductor is L, and this electrical symbol is this one, and what is the property of this. So this is what the property of this inductor. Comes to that third element of this particular electrical circuit is called the capacitor. Capacitor, it is denoted with C. The electrical symbol for this capacitor is like this, capacitor C. And what is the property of this capacitor? So it is the property, it opposes, it is the property of the capacitor, it opposes the change in voltage, or it is opposed the sudden change in voltage. So that is the property of these capacitors, and it can be measured in farad, farads, and it can be given as F. It is like 1 farad, 2 farad, or 2.5 farad. These are the particular value for any capacitor. Capacitor has 2.5 farad. So that is the value how we are going to assign to any particular capacitors. Now comes to that fourth element. The fourth element in this series, you can say here, is voltage source. Voltage source. So voltage source. So it is voltage source is an energy source. So this is the definition I'm writing, energy source, which gives which gives provide the constant voltage across its terminals irrespective of the current drawn, irrespective of current drawn by the load, you can say. So that is the definition for this voltage source. To understand this, let us will take the voltage source here. So this is my voltage source, and these are my terminals. I'm drawing my terminals, voltage source Vs. So at this voltage source from the AB terminal, here I'm connecting one load here, load. So when you are connecting some load here, it is going to draw some current by this load IL, and the voltage across your load is PL. So my statement here is my voltage source has to provide a constant voltage at this particular terminals, irrespective of the current drawn. Whether my load is drawing the current in any manner, my IL can be changes, maybe 2 amperes, 3 amperes, or whatever it is. But irrespective of my current variation, my voltage maintaining between these two terminals should be same. So that is the meaning for this voltage source. If you see the characteristics of this particular voltage source, then this is how we are going to draw. So this is going to, you can see it's a straight line is coming like this, and Vs is equal to here Vl. As my load current is varying in this direction, current is varying in this direction, but irrespective of the voltage or this current variation, my voltage is always maintained constant. So this is what the voltage source need to satisfy this particular condition, and this concept is applicable to the ideal sources. Ideal voltage source. We'll see the practical voltage source in the coming classes, but for this class we just understand what is the voltage source and what is the characteristics of this voltage source. The next element is current source. This is current I, current source. So definition of this, you can write, it is an energy source which provides the current, constant current at its terminals irrespective of the voltage appears across its terminals. So that is the definition of the constant this voltage source. To understand this, now let us consider a voltage source. So this is my voltage source, terminal here, AB terminal, and this AB terminal I am connecting load here, and this is IS. So this is drawing the current IS, and this is IL, and across the this load is the voltage is VL. So this is what. And what is my definition here is, I need to maintain the constant current across these terminals. I need to maintain the constant current across this terminal irrespective of my voltage variation. Irrespective of my voltage variation, my current source has to give a constant current. So that is the meaning of this statement. Now if you draw the characteristics for this ideal current source here, so this is what the VL and IS, and this is the straight line. It's coming like this. IL is equal to IS, you can see. So whether my voltage is varies irrespective of these points, always my current is providing to circuit is constant. So this is the definition for your current source, and which are the ideal current source. Ideal current source. Now we'll see what are the example for your voltage source and current source. So this is what your voltage source, right? We have a voltage source and this is my current source. What are the example for these two? We want to see. My voltage source, I can write. These are nothing but. So example for your voltage source: DC generators, DC generator, AC generators, batteries. Now comes to the current source. Here the example for current source are semiconductor devices. Semiconductor devices like we can take a transistor. So these semiconductor devices like transistor is going to act as a current sources, and your DC generator, AC generator and batteries are acting as your voltage sources. So these are the basic elements, total 5 elements we have seen: the voltage V and this current I, current source, voltage source, and your RLC circuits we have gone through. They are the basic elements of your electrical networks. Now comes to some terminology we need to define here. Active element. What is meant by these active elements? I will write the definition. So it is the active elements are the elements. Active elements are the elements which supply electrical energy or power to the network. Power to the network or circuit. That is the statement for active elements. So it is the electrical, it are the elements which supply the electrical energy to the rest of the networks. So which are the active elements here in this case? From out of the 5 elements, identify which are the active elements. So here active elements are, I can say, the voltage source and current source. Voltage source and the current source. These are the 2 elements. I can define them as the active elements because they are going to supply the energy to the rest of the network. They are going to supplying the energy to the rest of the network. So these are the example for active elements. Now comes to the passive elements. Passive elements. So passive elements are the elements which stores the energy or absorb the energy or dissipate the energy. are called the passive elements. So example for this passive elements, your R, L and C. So R will dissipate the energy. If you connect this R to the any active element, then it is going to dissipate the energy. But L and C will stores the energy. Will stores the energy. So that's why RLC you can call the passive elements. So which are absorbing the energy from the active sources. So that is the meaning of this concept. Now if I draw a diagram here, can you identify what are the passive elements and what are the active elements here? So this is my voltage source and resistance, one more resistance, and I'm assuming some inductance here, and this is my current source like this. R, L, C and voltage and current. Now from this network, if you see what are the active elements and what are the passive elements, so this is supplying energy, this is supplying energy, and this is also a supplying energy to rest of these networks. So I can say this one and this one are the active elements, isn't it? The voltage source and current source. Voltage source and current source are the active elements, and rest of this R, L, C, they are going to absorb the energy, and I can say R, L, C are my passive elements. Now we will see what is the difference between electrical network and what is difference between electrical circuit. So frequently we are using the terminology electrical network, electrical circuit in this subject. So what is the basic definitions and what is the difference between these two we're going to see here. So if you write what is the electrical network definition, the connection of various elements, various electrical elements means which are connected in any manner, which are connected in any manner, and that is called your electrical networks. Suppose for example, so I am considering, so this is my network, something like this, and it is connected something like this. It is opening VR1, R2 and R3. So I have different electrical networks here. I have different electrical network, elements here, R1, R2, R3 are elements and voltage source is the element, which are connected in any manner. They are connected in any manner, and this is going to form a electrical network. Sometimes you can see something like voltage source also connected like this, something like this, or it is coming like this and something like this maybe. This is also a network. Or sometimes if I connected the network like this, and this is also a network. So it means if more than two electrical elements are connected to each other in any manner, then that is called an electrical network. Now comes to here, what is the electrical circuit? The electrical circuit is a complete path. This electrical circuit is a complete path connected with elements, connected with these electrical elements through through which current can flow. Current can flow. So this is the statement of this electrical circuit here. So to understand this, so if you have take that number of elements which are connected, but it has to form a complete path. It has to form a complete path, then through which a current can flow. So this is the meaning of this. So I can say this is a electrical circuit. This is a electrical circuit. Why it is an electrical circuit? It has a complete path. It has a complete path to flow a current or circulate a current through this particular path. So my current is completely circulating in this circuit. My current is completely circulating in this circuit. So this is called a electrical circuit. This is called electrical circuit. Or some different circuit also you can show here. Something like this. This is also my circuit. You can say R1, R2 and R3. So this is also called a circuit. This is also called a circuit because this is a complete path is available to you to circulate the current, and here also complete closed circuit is available to you. So it is also going to circulate the current, and this is also a one closed path we have to circulate the current, and these are called electrical circuit. We have to see one note here. You need to remember this one. The circuit may be a network or a part of the network. Part of the network. So to understand this statement, I will explain you by taking this one. So this is I can say this is a network. I cannot say this is a circuit. Why? Because this does not have any closed path. So I can say this is a network, but it is not a circuit. But when it comes to this circuit here, this is I can say network or a circuit. This can be a circuit or this can be a network. You can define like this. But when it comes to this particular diagram, this is the part of this network. This is a circuit. Isn't it? This is a circuit. If you consider the whole diagram, then this is a network. So that is the statement of this meaning of this particular statement. Now we are going to define what is node, what is meant by branch, what is meant by loop, and what is meant by mesh. So in order to define this four terminology, so I'm going to consider a electrical network here. So this is the network I'm going to consider in order to define what is node, what is mesh, what is your loop, and what is branch. Let us consider. So this is the Stone bridge network. V, R1, R2, R3, R4 and R5. So this is the current I is flowing in this circuit. Again coming back, I'm going through this particular source. So this is what I'm considering. Now I want to define what is the node. So the definition of the node is a point where two or more elements are connected. More elements are joined together. Is called a node. is called a node. A point where two or more elements are connected is called a node. Now if you identify here, so at this particular point, 1, 2 and 3 elements are connected. So this is satisfying my statement, so I can make it as one node, node A. If you take this point, joining point here, R1, R5 and R3 as connecting. So this is also I can take as one node. Take this point here, R3, R4 and voltage source has been connected at this particular point, joining here. I can take this is one node, and at this point take then R2, R5, R4 as connecting. So this is also called a node. So in this particular circuit, how many number of nodes we have? Number of nodes we have equal to 4. So that is the meaning of node. Node means it is a point where two or more electrical elements are connected. Electrical elements are connected. Suppose this is the point, and if it is connected something like this, R1 and R2, then this point also called as a node. Isn't it? Two or more elements are connected at any point, then this particular point is called as a node. So that is the definition of this particular nodes. Now comes to the branch here. First we take the statement of this branch. The path between any two nodes is called a branch. It's called a branch. So the branch may be have one or more elements. The branch may be have one or more elements. So this is the statement. We will take this one. Now we are going to explain this. What is meant by a branch? A path between any two nodes. If you consider any two nodes, in between the A and B nodes, we have a R1. So R1 is called a branch. R1 is called a branch. Again, if you take A node and D node, in between these two nodes, one path is there. This path has been connected with R2 element, and this R2 element is called a branch. Similarly, you can say in between these two nodes, we have a R4, and R4 is called a branch. Similarly, between BC, R3 is a branch. In between BD, R5 is a branch. And in between A and C nodes, between the A and C nodes, this is the voltage source. This is also electrical element which is connected, and this is also considered as a branch. So that is the meaning of this particular statement. This is the statement meaning. Two are between the two nodes. If you have connected any branch, any electrical element, then it is called a branch. So in between two nodes. Then another statement is the branch may be have one or more elements. The branch may be have one or more elements. Suppose this is one node N1 and this is my node N2. In between these nodes, suppose the two elements are connected in series. If the two elements are connected in series, then these two elements combinedly can be considered as a single branch. Single branch. Remember, in between the two nodes, one or more elements are connected in series. Are connected in series. Then the combining of these two elements can be considered as a single branch, one branch. It may be have another element in between these two also. Then also R1, R2 and R3 also can be considered as a single branch. The another scenario is, suppose my network, my node N1 and N2 are there, and two elements are connected in parallel here, something like this. Two elements are connected in parallel, R1 and L, and this particular scenario I will consider this is a one branch, branch 1, and this is a one branch, branch 2. So here in this case the two elements are connected in parallel. I am considering as a branch 1 and branch 2. But if these elements are connected in series in between the two nodes, then all together and all elements can be combinedly considered as a single branch. So that is the meaning of this particular statement. Now we'll define what is the loop here. Loop is the closed path. Loop is the closed path for the flow of current. For the flow of currents. Loop is the closed path for the flow of current. For example, so this is, I can take as a loop, isn't it? So this is the closed path for circulating the current through this particular network. So I can say this is a loop. But when it comes to the definition for mesh is a loop. Mesh is a loop which does not have any other loops within it. So that is the statement for this particular mesh here. So the mesh is a loop, but it does not have any other loops. So for this loop, if you consider, there is another loop also inside, isn't it? So if I consider this is a loop here, and this loop can be taken as a mesh. This loop can be taken as a mesh. This loop also can be considered as a mesh. Because in this loop there is no other loops within it, isn't it? In this loop, so in this particular circuit, there is no other loops. In this particular circuit also there is no other loops. So these loops are called mesh. But when it comes to this green part, this green one, this one, so this is the loop we have, big loop. So in this big loop again we have a loops within it. So at this particular definition, so this can be called a loop, but this can be called a mesh. Mesh is a loop. Within it there is no loop should be present. So that is the meaning. So I hope you have understood the basic elements of this electrical engineering and what is node, branch and loop and mesh. So with this our fundamental concept as we have successfully explained. In the coming class we are going to start with that different laws, that Ohm's law and Kirchhoff's law.